Okay, these are the Mod 11 Part 1 notes, probability distributions. This is page 6. We are going to step back real quick, make sure we understand what we're saying when we talk about, oh my goodness, probabilities and probability distribution tables, and then we will get back into expected values and standard deviations. So we've got an experiment where we are flipping 5 coins. Again, our random variable x is the number of heads. So talking about the values that x can take on, here's my sample space, 1, 2, 3, 0, 1, 2, 3, 4, 5. Sorry, what I was saying and what I was writing wasn't matching. So we can calculate the probabilities of getting each of these outcomes. And I'm going to see if I can color code so this makes sense. So there's only one way to get 5 heads. Similarly, there is only one way to get 5 tails. I guess I could. And I wrote those backwards. So 5 tails would be 0 heads. I can't talk and think at the same time. Here's our 5 heads. Okay. So let's talk about how to get 1 head. So there's a head in the first spot. There's a head in the second spot. Let's see what else we have here. Here's our head in the third spot. Fourth spot. Fifth spot, if we're only getting 1 head, then we are just looking at hitting the 5 places that can happen. Similarly, if we want 4 heads, that would be the probability of 1 tail. So there's our first tail. There's the tail in the second spot. You know, I searched this all out, not as easy. Okay, there's our tail in the third spot, fourth spot, and fifth spot. So again, 5 ways to get 1 tail, which would be the same as getting 4 heads. So let's see our 2 heads. 2 heads right there. 2 heads right there. 2 heads, 2 heads. 2. 2 there, 2 there. What is that? 7, 8, 9, 10. 10 ways to get 2 heads. Because this is symmetric, there should also be 10 ways to get 2 tails, which would be our 3 heads. So let's see, 3 heads, there's 2, there's 3, 4, 5, 6, 7, 8, 9, 10. So the probability of 0 heads is 1 out of 32, 0.03125. We know that was the same for getting 5 heads. Go ahead and fill in on both sides. Probability of getting one head was 5 out of 32, which is 0.15625. We know the probability was the same for getting 4 heads. Probability of 2 heads was 10 out of 32, 0.3125. And same thing for getting 3 heads. And so we can fill in our probability distribution. Just a reminder that every single thing that could possibly happen in those 5 flips of a coin is represented in this table. So we do have a probability distribution here. We can also make a probability distribution graph or a probability histogram. This one I'm going to do. Let's see. Just to point out the shape. I am not going to worry about being too precise here, other than I really don't want to erase. There we go. So 0.03, I'm going to go about halfway below the 0 to halfway above. This is still a histogram, so these need to touch. Granted, I'm not going to get half a head. But realistically, as I'm figuring these out, anything 0.5 or above, I would round up to 1. Anything 1.4 or below, I would round down. So that 2 heads and 3 heads were the same. 4 heads is the same height as 1 head. And then 5 heads the same as 0 heads or 5 tails.